So we already kind of got a little bit of an idea about, like I said, what we were talking about today. So again, our objective. Oh, I thought I had my paper. All right, well, I'm not sure I put that. Okay, we won't worry about that for right now. Okay, but today we want to be able to solve a literal equation for a specific variable. Okay, so we'll call this literal equations. Which you could also think as solving for one variable when there are many. Okay, solving for one variable when there are many variables, of course, is what I mean there. Okay, so let me give you an example of that, right? Well, actually, let's take one step back. So, for example, how can we solve 42 equals 6x? Okay? How can we solve this equation, 42 equals 6x? Right? What would we do here? Okay. Yep, Alex, go ahead.
Divided by 6.
Okay, divided by 6. Why did you say divide by 6? What clued you in that was the case?
Because it's 6 times x.
6 times x, okay. And so you want to kind of undo that multiplication.
And turn it to division.
Yeah, so opposite of multiplication is division, right, okay. So we divide by 6. And so you said divide because we had to undo the multiplication. And why was it specifically 6 that you wanted to divide by there?
Because it was the only thing on the other side.
Because we're trying to solve for what? We want to get what by itself?
The x.
The x, that's right. So divide both sides by 6 because we're trying to get that x by itself. Okay? Right. So in other words, we rearrange, okay, the equation to get x by itself, or another word we can use is to isolate x, right? To put something by itself. Isolation, right? Okay, sometimes you're a prisoner, right? And you are like an extra bad prisoner, or you extra misbehave, they put you in isolation, right? And the idea is it's so awful to be by ourselves, right? And stuff like that, that you want to behave next and then, come back into the group and stuff like that, okay? Isolate, right? We want to get the x by itself. All right? Well, the same idea, okay, can be applied here for equations when there are multiple variables. We can do the same thing. So let's consider this equation, v equals L times W times H. Okay? This is an actual math formula here. Does anyone have a guess what it stands for? Yeah, it's volume. Volume equals length times width times height. It's the volume for a rectangular prism. Okay, rectangular prism there. Okay. So, there are many variables here, right? We have 4 of them. V, L, W, and H. All right, so we have many variables here to solve for. All right, so let's just pick one. Let's solve the equation for H. Okay, so this will be like an example here that we're going to do. Okay, we're going to take our equation there, v equals length times width times height. V equals L times W times H. And we want to solve the equation for H. Okay, it's the same kind of ideas here as before. What is with the H that we need to get rid of so we can isolate the H? What's with the H that we need to get rid of? Anybody? L and the W, that's right. Okay, so how can we go about getting rid of those 2 variables, the L and the W here? What should we do? What operation can we use to get rid of the L, for example? What do you say? Let's go to Liv. What do you say, Liv?
I was not gonna help
What's that?
you. I was not here.
Okay, but I think you can still answer the question, though. We're going to get the H by itself, right? There's this L here. How can we get rid of that?
Divide.
Yeah, divide both sides by what?
L.
Yeah, see? You knew what to do. Divide by L. Okay? What else can we divide by? What else do we need to divide by? A W, right? It's LWH. So let's go ahead and divide by the W at the same time there. Okay, we'll just divide by both at the same time. What's going to happen with these two L's on the right-hand side here? Cross out. What about the W's? They'll cross out. So we're going to have, now does anything cross out over here? No. So we're going to have to leave it V over LW, just like that. And equals what? What's still over? Oh yeah, H. Have we solved for H? Is H by itself? Yes, we've solved for H. It's done. That's our answer. Okay, that's our answer. We divided both sides by L and W. We got H. Okay? All right. You guys try one here. You guys take V equals L times W times H and solve, not for H anymore, I want you to solve this one for L. Okay? So you guys try this one. All right. Some of you might be able to just look at it and tell me what the answer is going to be. That's great. Do that if that's what you feel like you can do. But if you need to write it out too. Okay, so solve that equation there for L. Okay? Solve that equation there for L. Okay? Solve for L. Get the L by itself. Here's your answer. Okay. That L by itself. So if you don't want to divide by L, you want to keep the L, and you want to get rid of these two. Okay, so how could you get rid of those two? What operation can you do? Okay, okay there. Can you do it with one again? Retry this one. Retry this one. Retry your shot. Still write it down. Saw some people that were still writing it down when I was walking around, so I'll come around here. I'll give you another 15 seconds or so to try this out. Okay. I really would like you to write it down while I'm writing it down, so that way you can, do it when I ask you to. Okay, and not have to play catch up. Okay. All right. So Simon, you're on, bud. If we want to solve for L here, what should we do? Divide both sides by W and H. You got it. Okay? So the W's will cancel, the H's will cancel, and we're left with L equals V over W times H. Okay, exactly right. That's it. That's it. All right. Questions on any of that? Yes.
You still have to have the times. Do you still have the W times?
You can just have you have the W and H next to each other, that's fine. Because we understand, right, when the variables are next to each other, that means multiplication. So, yeah. All right, let's try some more here then. Okay, let's try some more. All right, and again, what we're going to do here is solve each equation. These will be our directions. Solve each equation for the indicated variable. So all these equations are going to have multiple variables, but our problem will show us what variable to solve for. Okay, so let's start with one. Okay, these will be, again, just some more examples here, some more practice. C, we're going to do some different kinds of problems than just the volume one there. C equals 2 times pi times r. Okay, there's our formula, and we're going to solve for the variable r. We're going to solve for the variable r. Okay? Now 2, that's a number, right? R, that's a variable. C, that's a variable. Pi, that's a number as well. Yeah, it's a number, okay? Technically, it's a Greek letter, right? It's a comma. And then R, because we're solving for R. I put the comma there to show we're indicating we're solving for R. Okay, that's why I put the comma there. Okay, so we're taking this equation, we're going to solve for R. Okay? But yeah, pi is technically a letter, but it's a letter used to represent the number, and always the number 3.1415926, etc. Okay. But yeah, that's a number there. Okay, so let's see here. So Hannah, how do we go about solving this for R? What should we do?
You have to divide 2 and pi by c.
Yeah, okay. Or I think you reversed. Yeah, we wanted to divide both sides by 2 pi, and so it'll be c divided by 2 pi. Exactly right. The 2's will cancel, the pi's will cancel. And so it's r equals c over 2 pi. Very similar to our volume formula there, but, you know, similar steps. But that's it. Mm-hmm. Okay. Questions on any of that? Yeah? I guess so. Are you understanding this stuff?
No.
And then you probably should stay if you can, unless it's an emergency, right? I think that's another thing, folks. Maybe I shouldn't, try and hold the bathroom stuff if you can until later. If you're having trouble understanding this, leaving would not be a good idea, unless it's an emergency, of course. Obviously, I'm not going to make you stay, but just thinking.
R equals C over 2 pi, or like C over 2 pi equals R.
Good question, right? So you can flip an equation around, it still means the same thing. So yep, that's still okay. Good question. All right, let's try another one. Let's see here. All right, this one might be a little bit funky, but we'll see. Well, because I'm going to throw in a square here, and I'm not sure if we're comfortable with squares, but we'll give it a try.
We're fine with
I'll throw it in here. Okay? A equals pi times r squared, and we want to solve for r. Okay? A equals pi times r squared, and we want to get the r by itself. Okay? So, Danny, do you have an idea here? How can we start trying to get that r by itself here? What would maybe be a good first step?
Getting rid of the pi.
Perfect. How are we going to do that?
Dividing it.
Divide both sides by pi. You got it. Well done. Okay. Divide both sides by pi. Pi's cancel. We now have a over pi equals r squared. Have we solved for just r yet? No. How do we know? It says r what? Squared. All right. Now here's where I don't know how much. Do you guys know how to cancel out a square? How to get rid of a square? It's not divided by 2, but I see what you're saying there because there's a 2 there and stuff like that. Yeah. The opposite of to square something is square root. Square root, right? So we can square root both sides. You guys have seen this symbol before, right? When you're working with like the Pythagorean theorem and stuff like that. Back in middle school, maybe. Okay? I'm pretty sure they talk about Pythagorean theorem in middle school and stuff. But anyway, there it is. Okay? So the square root of r squared is going to be r, and then, well, we really can't simplify the square root of a and pi because we don't know if they're perfect squares or not, so we'll just leave it like that. Okay. So do you guys remember the square root from before? Has anyone never seen that before in their life? Okay, so everyone has seen it before. Okay.
Or not admitting it.
What's that?
Or not admitting it.
Or not admitting it. That's true. But admitting you have a problem, Miss Mulcahy, is the first step to recovery. Anyway, all right. Maybe I'll avoid the square root stuff right now. Let me throw another one at you here. This one's going to be a little bit different. Changing it up just a little bit here. Okay. What's new about this literal equation that none of the other previous literal equations had? So, Sky.
It's slope.
Okay, so it is slope-intercept form. That's true. You recognize it. What operation is in here that wasn't in the other ones?
Multiplication.
Well, we have multiplication. What wasn't in the other ones? We didn't have addition, right? But we can still work with this. All right. Let's say we are going to solve for b. I'll make this one a little bit easier to start out here. Let's say we're going to solve for b. Okay? But it could still be a little bit tricky. We'll see. Okay? So we're going to take this equation, get the b by itself. Well, what do we need to get rid of that's with the b here? I'm going to go to someone here. Let's go to Matt S. What do you say, Matt S? What's with the b in that on that equation there that we need to get rid of?
What's with the B?
Well, yeah, what's on the same side, I should say, as the b, right? What do we need to get rid of to get the b by itself? mx. How can we get rid of it? Subtract mx from both sides. Very good. And I like that Matt didn't try to break up the mx or anything like that. You can subtract that product from both sides because it was being added to the b there. So you can straight up subtract mx from both sides. So good job there, Matt. Okay, Matt, is y a like term with mx? No, we can't combine them. So instead we're just going to write y minus mx. That's the best we can say. And that's equal to b. Okay? We can't combine them. They're not like terms, right? Just like we couldn't divide c by 2 pi. We couldn't divide a by pi. They're not like terms. Or like it's not possible to divide there. Here we cannot subtract this. So we just have to rewrite the subtraction. Is Matt done here? Did he get the b by itself? Yeah, the b is by itself. He's done. Okay, that's fine. Yeah, that's it. He's got it. Okay, good job, Matt. All right, now, we're going to take the same exact equation. Oh, question, Sean? You're feeling okay now? Okay. We're going to take the same equation, but I'm going to change what variable we're going to solve for. Okay? Now let's take that y equals mx plus b, which Sky correctly identified as slope-intercept form there. Let's solve it for x. Okay? So we're going to take the same equation, solve for a different variable. Okay. Did Reagan get you straightened out there, Liv?
Yeah, I wrote it.
Okay, I got you. Okay. Same equation. Now we're going to solve for a different variable. And we're going to go to Simon. Simon, your number's up again. What do you say here, Simon? Well, how can we start solving for x? How can we start getting x by itself here? What should we maybe do? Ah, I like that Simon said subtract b from both sides first. Some other people might look and say, oh, but Mr. Widd, there's an m next to the x, and we'll take care of that m after we take care of the b, right? We want to subtract the b first from both sides. Question, Matt?
Does it matter?
So, kind of, but I think when you see an equation like 10 equals 2x plus 5, right? What do you always do first in a situation like this? Subtract the 5 and then divide by the 2, right? Same idea here, except we just have variables in those places, but it's the same principle, Matt, I would say. You can divide both sides by m first, but I'd suggest you get rid of the b and then divide by the coefficient, the m there with the x, okay? You can do it, and I can show you what it looks like if you do it that way. It's trickier than what you might expect, I think, but anyway. Okay, so now we have y minus b, because again, they're not like terms, equals mx. All right, Tyler C., what are we going to do next to get the x by itself here?
I would say divide.
Divide both sides by? M. Good job. Okay, now there's a couple ways you can write this when you do the division over here. Okay, the m's going to cancel with the x, right? So we'll just have an x by itself, x equals. But you have some choice about how you want to write this. You can leave it as y minus b over m, like this, okay? Or, I'm going to put a little equals here because you can see the other way. Or you can divide each term by the m. You can break up the division is what I'm trying to say. So we can say y over m minus b divided by m. Either of these things are saying the same thing. Y minus b divided by m is the same as y divided by m minus b divided by m. Okay, either one's okay there. Your choice, but you need to recognize that both of these are the same. Okay, you can break up the terms and divide them each individually with the subtraction there. Okay, so this one or this one. All right, you guys ready to try one or two on your own now?
Yes, sir.
All right. I was expecting having to take your silence as a yes, but people actually said yes. That's good. All right. Sir, yes, sir. Woo. Okay. So let me give you a few here to try on your own. All right. So how about try these? Okay. Number 1. D equals M divided by V. Does anyone recognize this formula from science class? Not diameter, nope. Density is mass divided by volume. That's right. Mm-hmm. Very good. I was going to say, your science teachers are just like, woohoo right now. Okay. So we're going to solve this one. Okay, we're going to solve this one for M. And then I'm going to give you the same. Actually, no, I'll do something different in mine. I don't want to make it too crazy here. How about number 2? 2L plus 2W equals P. And I want you to solve that for L. I should write that here. Back on the screen. Okay, and I'll do a third one here. I'm going to give you the same density equals mass divided by volume, but I'm going to ask you instead to solve for V. And that one's going to be a little bit trickier, so if you get stuck on that one, that's okay. Give it a try. But at least do 1 and 2 there. Okay, at least try 1 and 2. Okay, so for number 1, D equals M over V, solve for M. Number 2, 2L plus 2W equals P, solve for L. Number 3, D equals mass divided by volume, solve for V volume. So give those a try. I'm going to walk around and see if you need help or anything like that. I see. Yeah, that one's not quite, but that's okay. We'll go over it. This one looks good, and this one looks good too. Okay. If you want to try and rework that one, maybe give it a try. Yeah, you're feeling okay on this stuff. Yeah. So far, so good. Try that first one. See what's wrong with that first one. Okay. D equals M divided by V. Solve for M by itself. Multiply both sides by what? Look at M by itself, and M is being divided by V. Multiply both sides by what? V. Oh, okay, I see now. So, to get the M by itself here, what's with the M that you need to get rid of? The V. And it's being divided by V, so what you need to do both sides? Multiply both sides. Well, now, we'll come back to this. This one's a little bit different, so, but this one is, that's what you got to do for now. Let's fix that one first. Let me see how it's Okay, so P is also being divided by 2, so we put 1 half P over here with 2 there, but that's okay too. Okay, so they both get divided by 2. Okay, so here, okay, so to get rid of that 2L, it's, the 2L is being added to 2W, so you should subtract it from both sides first. Okay? It'll be 2W equals P minus 2L. Oh, sorry, you're solving for L. Sorry. It'll be 2L equals P minus 2L. You want to subtract 2W over both sides. So, well, here's why. You need to write this down. Okay, you're trying to just do it all. See what I'm saying here? Cancel that out. 2L equals P minus 2W. Okay, then you get L by itself. What's your next step going to be? Well, you have 2L. You need just L out here. That is 2L 2 plus L.
gonna
Write that one.
need to fix something.
Okay, that one's good. What about this
Just
one?
fix it once.
You got it, but you're trying to get Mr. Wade away from you. Mr. Wade, go away. I don't want any help. But you can do it. So what would be your first step there?
Yeah.
The L by itself. Let's put the L there. You got to do it. Okay. You'll have to divide or subtract, right? I think that's doing subtraction first. So minus 1 on both sides. 2 W.
Sisters, one of my sisters.
Okay. Look, folks, we're going to go over this here, okay? Y'all got to learn to speak up. And by speak up, I mean ask questions, all right? I'm walking around. I'm seeing people that are just like staring at their paper. They're not putting their hand in the air. They're not asking questions. I mean, you got to stop me and ask questions, okay? You got to engage your brain here and be like, don't just like blindly write stuff down, right? We got to ask questions. So let's go over this here. All right, number 1, D equals mass divided by volume, right? How do we get M by itself here? What do we got to do to both sides? Yes, Matt T. Multiply both sides by V, exactly right. D equals M over V times V times V. The V's cancel. You get M equals dV. M's by itself. I'm going to do this in red, actually. It'll stand out a little bit better, I think. All right. Number 2, let's go to, well, Sky. Sky, were you able to get the L by itself there?
Yeah.
Yep. Okay. What'd you do for your first step? Subtract 2W from both sides. Great idea. Okay. 2W goes away. We're left with 2L over here. And then P and the minus 2W, those are not like terms, so we can't put them together. Sky, were you done, or you still have something else to do here? I see what you're doing, but then you're going to have an L over here, though, too. Divide both sides by what? 2. We want to get the L by itself. We want to get rid of that 2. So divide both sides by 2. So we get P minus 2W all over 2. Now, Tyler C simplified this sum, right? Okay, so you could leave it like this and say you're done. But Tyler wasn't satisfied with that. He saw he could simplify it some, and he did. Tyler, what did you simplify this to be?
L equals
P minus 1W, and it was P over 2, wasn't it?
Yeah.
P over 2. Okay, so P divided by 2, P over 2. 2W divided by 2, 1W. So you can divide like that, okay, and break it up. So either one of these is okay. Okay, either one of those is okay. All right, then number 3, this one causing people some trouble here. All right, number 3 causing people some trouble. So let's take a look at number 3. We want to solve for V. Okay, so Hannah, you think you got it? Okay, so divide both sides by M. All right, we can do that here. So let's see. That'll be D over M equals 1 over V, like that. And then what do we do? Once we divide both sides by M, we have a good. Oh, okay. You were on something there.
Times the 1?
Times 1 on both sides. Yeah, but if we multiply both sides by 1, it'll be the same thing. So let me try a different approach here, because Hannah was like onto something there, but I want to do something different here. So we're actually going to take the same step we did for the first one here. D equals M over V. We want to get the M by itself. Okay, first. Actually, sorry. Let me back up. We want to get the V out of that denominator, because that's what's kind of causing some problems here, right? We're not sure how to get rid of. We have something in the denominator. So how can we get the V out of the denominator? What should we do to both sides here? All right, go ahead, Matt. Multiply both sides by a V. You got it. Okay, and so we get M equals V times D. Okay. Now, how can we get V by itself here? I'm going to pick someone, Matt. Hang on. So let's go to Kendall. What do you say, Kendall? At this point now, how can we get the V by itself? Divide both sides by what? D. Yeah. Okay. D's cancel. We're left with V equals M over D. And so there it is, solved. Okay. So we had to do kind of like a weird step here, getting the V out of the denominator. But then once it was very easy to see, oh, just divide both sides. Okay. So That's all I've got to say. Questions on anything about that? All right, then, if you guys would get your books out, I'm going to show you what the homework's going to be. We got homework over the weekend. Well, if you remember, Ms. Wilmeyer didn't give you homework for like a couple days in a row this week, so I feel like it's okay to do it now.